All right, then. We're diving deep today into, well, I think you could call it a pivotal moment
Oh, absolutely.
in space exploration history, the Apollo 9 mission.
Mm.
Everyone thinks about Apollo 11, the moon landing, the ultimate triumph. But Apollo 9
Oh, it's crucial.
laid the groundwork in a way that, well, was really extraordinary, wouldn't you say?
Absolutely. I think the lunar landing really captures the imagination, but it was Apollo 9 that rigorously tested the hardware
Yeah,
and the procedures in Earth orbit, a proving ground.
exactly. And that is our mission today,
Okay.
to understand just how Apollo 9 validated the lunar module, the LM, in Earth orbit.
Right.
So we're going to look at the goals,
Okay.
the outcomes, and the timeline of this. Well, it was a 10-day flight.
Mm.
Now we've got a lot to draw on.
Right.
My notes from, well, just this week, the 4th.
Uh-huh.
So Apollo mission overviews, we've got crew bios, mission timelines,
Wonderful.
and, well, a study guide just to make sure we don't miss anything.
Excellent. Well, you know what I think is so interesting about Apollo 9 straight off is it was the first crewed flight
Yeah.
of the complete Apollo spacecraft configuration, the CSM and the LM together, the whole suite.
It was. Which brings us to, I think, the first thing we should talk about, the call signs for this mission,
Yes.
Gumdrop and Spider.
Mhm.
Now, that wasn't just, a bit of fun from the astronauts,
No.
was it? There was actual significance behind it.
There was real significance. So before Apollo 9,
Right.
NASA had this policy against naming spacecraft,
Right.
which had come about because of that incident with Molly Brown during Gemini 3.
Right.
But Apollo 9, you see, was unique because it was the first time the CSM and the LM were going to separate
Okay, yeah.
and operate independently before they redocked.
So they needed names so they could...
They needed separate call signs
Yeah.
to be absolutely clear
Yeah.
when they were talking to each other.
Right. Okay, so where did these sort of funny names come from? Gumdrop and Spider.
Well, the astronauts came up with them during their simulations.
Okay.
Gumdrop was because when the command module was being transported, it had this blue protective covering
Okay.
that looked like a gumdrop suite.
I can see that.
And Spider came from how the lunar module looked when it landed with its legs deployed,
Right, like a spider.
like a spider.
What did NASA think about this? I bet they were a bit, I don't know.
Well, they were a bit unsure at first. They thought the names were a bit informal,
Yeah.
but the astronauts argued that they'd make communication much clearer
Right.
during the separation and redocking.
Because those were such crucial moments.
Yes, absolutely crucial. And so they allowed it.
So they were pragmatic,
They were pragmatic in the end.
but it didn't really set a precedent, did it?
No, they went back to more formal call signs with Apollo 11.
Right.
So Gumdrop and Spider were just this brief but sort of important moment where operational needs kind of won over formality.
Yeah. It's interesting, isn't it, that sort of push and pull between, well, the rules and what actually has to happen.
Yes.
Okay, well, now that we've got our spacecraft named,
Right?
let's talk about what the Apollo program was all about, what the goal was, and how Apollo 9 fit into all of that. I mean, obviously, the big goal
Yeah.
was to get humans on the moon
By the end of the decade.
by the end of the decade. Yeah.
Exactly. And to do that, there were lots of stepping stones.
Yeah.
They had to develop and test the spacecraft themselves.
Right.
The CSM and the LM, and of course the life support, the EMU,
The suits.
the suits, yes, and the PLSS, the portable life support system.
Right.
Apollo 9, it was the first crewed flight of the whole spacecraft.
Yeah.
So it was really important for validating the lunar module.
Yeah.
That was its main objective.
Right. And it wasn't just about the hardware, was it?
No.
There were these very complex procedures they had to perfect, like
Launching on the Saturn V.
launching on the Saturn V, exactly, making adjustments to the orbit,
Yeah.
and crucially for Apollo 9, rendezvous and docking.
Especially between the CSM and the LM.
Right.
Absolutely crucial for lunar orbit and for the landing itself.
Yeah.
Apollo 9 was the first real demonstration of that procedure.
Right.
And it was the second time the U.S. had docked 2 crewed spacecraft.
Okay.
And then, of course, they had the EVAs.
Right. The spacewalks.
The spacewalks, yes. They needed to understand how astronauts could work outside the spacecraft.
Yeah, for the lunar surface.
Exactly.
And all of this had to be learned in space.
It did.
It wasn't just a case of,
Taking things off a list.
ticking things off a list. It was about
Developing the skills.
Developing the skills.
Gaining experience.
Gaining the experience, yeah. At Apollo 9's 10 days in low Earth orbit. That was
Yes.
quite a long time, wasn't it?
They
to test everything.
It was comparable to an actual lunar mission, so
Right.
they could test everything properly and see how it would perform over a longer period.
Okay, and of course safety was,
Huge.
yeah, it was a huge consideration, especially after
Apollo 1.
Apollo 1, exactly. So how did Apollo 9 contribute to that, to making sure everything was safe?
Well, after the fire, the whole Apollo program had this big safety review.
Right.
They had uncrewed missions like Apollo 5, which tested the lunar module,
Okay.
and Apollo 7, which focused on the command and service modules.
Right.
Apollo 9 built on that by testing the LM in a crewed environment.
Right.
So they were bringing in the human element
Yeah.
to the testing.
Right. And of course, this was all happening
Under pressure.
under pressure
Yeah.
because of Kennedy's deadline.
Yes, that deadline to land on the moon before the end of the decade. Apollo 9, which was originally the D mission,
Right.
was all about testing both the CSM and the LM in Earth orbit.
Yeah.
It was crucial for keeping the program on schedule.
Okay.
Its success meant they could go ahead with Apollo 10.
The dress rehearsal?
The dress rehearsal, yes.
Right.
And then, of course, Apollo 11.
The real deal.
Real deal.
They even considered accelerating the program.
They did, after Apollo 9 was such a success.
So it really was.
A pivotal mission.
Yeah, a pivotal mission. Okay, let's talk about those EVAs.
Right,
Those
okay.
dual extravehicular activities, the spacewalks. These were not just, for fun.
Yeah.
They had very specific objectives for those future lunar missions.
Absolutely. It was all about testing equipment.
Right.
And refining the procedures they would need on the moon.
Right. Let's start with
Rusty Schweikart's EVA.
Rusty Schweikart's. Now, that sounds like a rather
Ambitious one.
ambitious one. Yeah.
So his EVA was on day 4 of the mission.
Okay.
And the main objective was to show that an astronaut could transfer from the LM hatch to the CM hatch
Okay.
from the outside if there was an emergency.
Right, right.
This was also the first flight test of the EMU backpack, with the PLSS.
Right. The PLSS, the backpack.
A backpack, yes.
Yeah. It's what keeps them alive, essentially, isn't it?
It is, yes. It provides oxygen and cooling.
Right.
It regulates temperature outside the spacecraft.
Okay, so it's got the oxygen, it's got the cooling.
It's got water for the liquid cooling garment
Right.
and a backup oxygen supply, the oxygen purge system.
So Schweikart went out of Spider, the lunar module,
It did.
and moved around using those
Handholds on the outside.
handhelds. Yeah.
Interestingly, he said it was easier to move around the LM than it had been in the simulations.
Well, that's good.
That was good news. He and Scott, who was in Gumdrop at the hatch,
Right.
took pictures of each other.
Okay.
And they retrieved some experiments from the outside of both spacecraft.
Right.
They didn't need to do the full transfer to the command module,
Yeah.
but they were confident he could have done it.
Right.
Oh, and Schweikart used the call sign Red Rover during the EVA.
Red Rover.
Red Rover, because of his hair color, you see.
Ah, I see. Okay. So Scott did an EVA on the same day.
He did, but a different kind, a stand-up EVA.
Stand up, yeah.
He did it from inside the hatch of the command module,
Okay.
and he wasn't wearing a PLSS.
Great.
He was connected to the CM's life support by an umbilical,
Okay.
and he used something called a pressure control valve, a PCV.
PCV, what was that for?
Well, it was developed in 1967 for stand-up EVAs
Okay.
from both the LM and the CM hatches.
Right.
And for any quick trips outside,
Right.
in Scott's EVA, he was mainly helping Schweikart
Right.
and taking pictures of him.
Okay.
And that same PCV was used later by Scott himself on Apollo 15
Right.
during his lunar EVA and for the deep space EVOs
Wow.
on the last 3 Apollo missions.
So that's a good example of how something they tested
Yeah,
turned out to be useful in all sorts of ways they hadn't even thought of.
exactly. It shows how important testing is. You
Yeah.
never know what might be useful later on.
So those EVAs were really important then.
They were crucial. It was the only chance they had to test the PLSS in space before the moon landing.
Yeah.
And it proved they could do an emergency transfer
Right.
between the modules if they needed to.
Okay, so now let's talk about docking.
All right.
That was essential for a lunar landing, wasn't it?
Absolutely essential.
If you couldn't dock the lunar module with the command module,
It wouldn't have been possible.
the whole thing wouldn't have worked. Apollo 9 had
2 docking events.
2 docking events, right?
Yeah.
Let's start with
The initial docking.
the initial one. So that happened soon after launch.
Yes. As soon as they reached parking orbit,
Right.
Gumdrop, the CSM,
Yeah.
separated from the SIVB,
Okay.
and then docked with Spider, the LM, which was still attached to the SIVB.
Right.
David Scott, the command module pilot, he did the docking.
Okay.
They used the Proven Drogue assembly, and it worked perfectly.
Good.
McDivitt and Schweikart then went through the tunnel
Right.
to inspect it, and they also showed they could maneuver the docked spacecraft
Go
using the SPS engine
with a short burn.
with a 5-second burn.
So that first docking went well.
It did, but then came the separation and rendezvous.
Yeah, that was they called it the
key event.
the key event of the whole mission.
Of the whole mission.
It was simulating what would happen
Lunar orbit.
in lunar orbit after the LM came back up from the surface.
Exactly, and this time,
The LM was the active party.
Spider was in charge.
Spider was in charge, yes, with McDivitt piloting.
Right.
Scott inspected Spider from Gumdrop.
Right, to see if it would...
Sure, there was no damage.
Yeah, no damage. And then the final docking.
Ah, yes, that was tricky.
That was tricky, yeah.
McDivitt was doing the docking again,
Yeah.
but he had trouble because of the sun glare.
Right.
Scott had to talk him through it,
Guide him in.
guide him in, yes. And that actually highlighted a potential problem for the lunar missions,
Right.
because in lunar orbit, the command module pilot would be responsible for the docking.
Okay, but overall, those dockings, they were a huge achievement, weren't they? Huge. They proved the lunar module could operate, and the crew knew what they were doing.
It gave them confidence for Apollo 11.
It did. It paved the way.
Okay, let's talk about qualifying the lunar module, because that was
The primary objective.
the main objective of Apollo 9.
Yes.
It wasn't just about docking. It was about making sure the LM could do everything it needed to do,
Absolutely. They tested all of its systems.
starting with the engines.
The descent and ascent propulsion systems, yes.
We talked about them firing the descent engine with the whole spacecraft attached
As a backup.
as a backup, yeah.
But they did much more than that.
What else did they do?
Well, the crew actually went into the LM to do system checks.
Right,
And then that firing of the descent engine, it wasn't just a demonstration.
right.
It was a 367-second burn
Wow.
that simulated the throttle pattern for a lunar landing.
Okay.
And after Spider separated from Gumdrop,
Yeah.
they fired the descent engine again at different throttle settings
Right, to really put it through its paces.
to see how it performed.
And the ascent engine.
Ah, yes, they fired that remotely from mission control
Wow.
until it ran out of fuel to simulate a lunar ascent.
So they really did test those engines
Thoroughly.
thoroughly. What about independent operation? Could the LM operate on its own?
That was crucial too.
Right.
So after that first docking, McDivitt and Schweikart transferred into Spider.
Okay.
That was actually the first time American astronauts transferred between spacecraft without an EVA.
Really?
Yes, it was. They closed the hatches, which proved the LM's communications and life support worked independently.
Right.
They even deployed the landing legs to make sure they worked.
Right. So it really was its own spacecraft.
It was.
And then, of course, there was the rendezvous and docking again.
Yes, but this time from the LM's perspective.
Right. So after the independent flight and the engine tests.
Spider lowered its orbit to rendezvous with Gumdrop.
Right.
It was a close simulation of what they'd do on a lunar mission. And Spider was the active party again, showing it could handle that role.
Right.
And McDivitt docked successfully with some help from Scott.
Right. Because of the...
The sun glare, yes. Now, this was really important because the LM couldn't come back to Earth on its own.
Right.
It had to dock with the CSM.
Yeah, that was essential.
Yeah.
And, of course, there was the EMU testing
Oh, yes, the spacesuit.
during Schweikart's spacewalk
That was the first flight test of the full EMU backpack
with the PLSS.
with BLSS. It showed they could use it for EVA.
Right. They could actually survive.
They could survive, yes. And it gave them data to plan the lunar EVAs.
So they really did test the LM extensively.
They did. There was only one system they couldn't test fully,
Which one?
the landing radar.
Right. Because that
The
needed
conditions in lunar orbit.
the conditions in lunar orbit, yeah. But overall, the LM passed the test, didn't it?
Oh, yes, with flying colors.
So Apollo 9 was a success in that regard.
A complete success.
It showed the LM was ready,
Ready for crewed spaceflight?
and that meant they could go ahead with.
Apollo 10 and 11.
Right. Okay, let's look at the timeline for this mission, because it wasn't just
Random events.
days of random events. It was carefully planned.
Very carefully planned. It's important to understand the background, too.
Yeah, go on.
So the crew, McDivitt, Scott, and Schweikart, they were chosen back in April 66
Right,
to be the backup for the first crewed Apollo flight.
right,
But then, of course, the Apollo 1 fire happened,
right.
And that changed everything. They had a big safety review,
Right.
and they changed the mission designations.
Right.
What was going to be a rendezvous mission with an uncrewed LM became the D mission,
Right.
which was all about testing the CSM and the LM in Earth orbit,
Which became Apollo 9.
which became Apollo 9, yes.
Right.
McDivitt even decided to stay with this mission
Okay.
instead of flying on Apollo 8 to the moon,
Why?
because he wanted to stick with his crew on this important mission.
Okay.
And there was that crew swap that put Armstrong's crew in line for the first lunar landing.
Right.
The Apollo 9 crew did a massive 1,800 hours of training.
Wow.
And then the launch was delayed because they all got cold.
They all got colds.
They did. It's funny, isn't it, how these little things can
Yeah.
affect these huge missions.
So they launched on
March the 3rd, 1969.
March the 3rd, 69.
A few hours after reaching orbit, they separated from the SIVB
Yeah.
and docked with the LM.
Okay.
They did multiple tests of the SPS engine, the CSM's main engine.
Okay.
By day 3, they'd entered the LM,
Right.
deployed the landing legs,
Right.
and done that first in-flight firing of the descent engine.
Okay.
Day 4 was the EVAs with Schweikart and Scott,
It's a spacewalk.
the spacewalks.
Right.
Day 5 was the key event,
Yeah.
the LM undocking, the independent flight, the engine tests.
Right.
They jettisoned the descent stage and redocked with the CSM,
Okay.
and then they jettisoned the ascent stage and fired it remotely.
Wow.
The rest of the mission was about testing the CSM systems,
Right.
doing Earth photography with a multispectral camera, and navigation exercises.
Right.
They came back on day 11, but it was delayed because of bad weather.
Okay.
And they splashed down in the Atlantic
Right.
and were picked up by the USS Guadalcanal.
So the mission itself was a success, but there were things that happened afterwards that were significant as well, weren't there?
Yes, there were. So a few weeks after Apollo 9, NASA said Apollo 11 would be the lunar landing mission.
Right.
And the crew went on to do different things.
Yeah.
McDivitt became manager of the Apollo spacecraft program.
Okay.
Scott commanded Apollo 15 and landed on the moon.
Wow.
And Schweikart, well, he never flew on another mission.
Right.
The LM stages and the SIVB either burned up in the atmosphere or went into solar orbit.
Okay.
And the command module, Gumdrop, is now in the San Diego Air and Space Museum.
Right. So it's a museum piece now.
Oh, yes, yes.
So let's go back to the main point.
Qualifying the lunar module.
Qualifying the lunar module. This was only the third human spaceflight for NASA.
Yes, but the first with the complete Apollo spacecraft
And a full crew.
and a full crew.
And it was all about proving the LM could do what it needed to do
To lunar orbit.
for lunar orbit. Yeah.
Right.
They showed its propulsion systems worked. It could fly independently,
It could rendezvous and dock
rendezvous and dock. And they also showed that the descent engine could be a backup.
to the CSM's main engine.
Right. And they tested the PLSS
In space.
in space. So it was,
It was a remarkable achievement.
yeah, first crewed flight of the LM, the docking, the two-person EVA, the second crewed docking ever,
The descent engine firings, the LM rendezvous,
CSM testing, Earth photography, they did it all.
they did. And NASA's assessment,
Well,
complete success.
complete success. It exceeded expectations.
It did.
It showed the LM was ready, and it set the stage for Apollo 10 and 11.
It did.
So you could say Apollo 9 was the lunar module's
Debut.
debut. Yeah, it's coming out party.
It proved what it could do.
It wasn't about getting to the moon.
No.
It was about proving the vehicle that would take us there. Okay, well, I think we should look at this study guide.
The mission study guide.
Yeah, the mission study guide, because it has some
Insight.
interesting insights.
Yes, it does. The quiz questions really highlight the key points.
Okay, like what?
Well, first, the primary objectives were all about testing the LM,
The propulsion.
the propulsion, the life support, and the rendezvous and docking.
Right,
And it also points out that this was the first flight of the whole Apollo spacecraft
right, altogether.
altogether, which meant they could test that crew transfer
Right, between the modules.
between the modules
Mhm.
and the descent engine as a backup.
Yeah, that was important.
That was crucial, especially for Apollo 13.
Apollo 13, yeah, it really highlights that.
It does, and it also talks about the impact of the Apollo 1 fire
Right,
and how it changed the mission designations and led to Apollo 9's role.
okay. So
And then there's the probe and drogue assembly,
the docking
the
mechanism.
docking mechanism, yes. Vital for connecting Gumdrop and Spider. And it mentions the call signs Gumdrop and Spider,
Yeah, Gumdrop and Spider.
how they were important for identifying the modules
Right.
when they were separated.
Right.
And of course, the PLSS gets a mention.
Yeah.
The first use of the full PLSS in space
During Schweikart's spacewalk.
during Schweikart's EVA. It showed that it could provide life support for lunar EVAs.
And it reminded us of the key event.
The LM rendezvous and docking.
Right. Crucial for the lunar landing.
Absolutely.
And they did some other interesting things too, didn't they?
They did. They took pictures of the Earth with a multispectral camera.
Right, which led to
Earth observation satellites.
Earth observation satellites, yeah.
And the study guide really emphasizes the overall significance of the mission.
Which was?
It proved the LM could do it, and it allowed them to go ahead with Apollo 10 and 11.
So a very important mission, perhaps not as well known as some of the others.
But crucial nonetheless.
So to sum up, what are the key achievements of Apollo 9 and why was it so important?
Apollo 9 was a success. It did everything it set out to do.
Right.
Testing the lunar module in Earth orbit was essential for the moon landing.
Yeah.
It proved that the LM was a real spacecraft, that it could fly on its own, maneuver in orbit,
Really?
and operate in space.
It was a huge step forward.
It was a blend of innovation and problem solving.
And bravery.
And bravery, yes. The crew and the mission control teams did an amazing job.
They did.
It shows how complex it was to do this with the technology they had in the 60s.
Yeah, and the lessons they learned.
They're still relevant today.
They are. So I want you to think about this.
Okay.
The audacity of it all. To do something as complex as Apollo 9.
Yes.
With the technology of that time, it was a huge achievement.
It was.
What aspects of this deep dive do you want to explore further? The engineering of the lunar module, the orbital mechanics, the stories of the crew. There's so much out there.
There's so much to learn.
There is. Join us next time for another deep dive.